Hi everyone, today we are going to solve a problem on a regenerative cycle. So, this regenerative cycle problem involves in a single heater regenerative cycle, the steam enters the turbine at 30 bar and 400 degrees Celsius. Condenser pressure is 0.01 bar. The feed water is open type, operates at 5 bar. Find the efficiency and steam rate of cycle. So the general layout of a regenerative cycle looks like this. So the first of all, the steam enters the turbine at 30 bar and 400 degrees Celsius at point number 5. The steam entering at a point 5 in the turbine, it expands till the point 7. So it expands till the point 7. So while expanding, we take in a regenerative cycle, we take some amount of the steam and we mix it with the water from the condenser at the feed water heater at point number 3. So it is a turbine in which the expansion takes place from 530 bar to 0.01 bar, but at a 5 bar the steam is taken out and it is then mixed with the water from the condenser, hence increasing the heat of the water entering the boiler. So what happens here is 1 kg of steam is entering from the boiler into the turbine. So here in a turbine at a pressure of 5 bar, when there is a partial expansion, the steam is taken out. Some amount of steam is taken out. The amount of steam is m kg. Out of 1 kg, m kg is removed. Then it is what remains is 1 minus m kg. So 1 kg is the steam entering the turbine. Out of 1 kg, we remove m kg, then what remains is 1 minus m kg. So this 1 minus m kg expands through its way till 0.01 bar. So 5 bar, some amount of steam is taken at 5 bar and the remaining amount of steam expands through the turbine. So then it gets into the condenser at 0.01 bar, that is 1 minus m kg amount of the steam is converted into water. Then it is pumped in a pump number 1. This is the pump number 1 from H1, that is 1 to 2 is the first pump, then 3 to 4 is the second pump. So first 1 to 2 is 1 minus m kg. Here 1 minus m plus m. We can write 1 minus m plus m. So m gets cancelled. What remains is 1 kg. So at this point number 3, where the meeting point of m and 1 minus m, what remains is 1 kg of steam. It is pumped from point number 3 to 4 with increasing temperature. So here it is from 4 to 5, again heat is being added. So we can, to solve this problem, we will move ahead. So we move ahead and start solving the problem. So we can see here at a point number 1, what is the pressure? The pressure is 0.01 bar. So what is the condition of the steam at 1? The condition of the steam at 1 is fluid. We know that this is a saturated liquid line. This is a saturated liquid line. Whenever anything lies on this line, it is considered as HF. It is enthalpy of the fluid. So we have to move to the thermodynamics data handbook. So as we look at the thermodynamics data handbook, at a 0.01 bar, we can look here. This is a pressure based chart. Pressure based chart. This is a pressure based chart. Here we look at our value of pressure in the condenser, that is 0.01 bar, zero point zero 0.01 bar, and we have to find out the enthalpy of the fluid. So if we look at the enthalpy of the fluid, what we can see here is 29.3 kilojoule per kg, that is HF, because our point number 1 lies on the saturated liquid line. So we note down HF is equal to H1, that is 29.3. So after noting down the value of H1, now what we do is we go to the next point, that is point number 2. How to find the value of H2? So before finding the value of H2, we will find the work of the pump number 1. Where is the work of the pump number 1? WP1 is 1 to 2. So WP1 is 1 to 2. The pump number 1 is pumping the water from a pressure of 0.01 bar to a higher pressure of so to a higher pressure of 5 bar. So what does the formula becomes is Vf, that is the volume of the fluid at 0.01 bar, and P2 minus P1, that is 5 bar minus 0.01. So we look at the data handbook, we know that our volume of the fluid at point number 1 is, volume of pressure of the fluid at point number 1 is 0.01 bar. So we note down the volume of the fluid. So, noting the volume of the fluid at a condenser pressure of 0.01 bar. So, we can look here what is the pressure. 0.01 bar is the pressure, and what is the volume of the fluid. If we go along this line, we can note down the volume of the fluid at a pressure, condenser pressure of 0.01 bar, that is volume of the fluid is 0.001 meter cube per kg. So we will move to our note down this volume of the fluid and calculate the pressure. So what we are doing here is note down the value of the volume of the fluid, then this is the volume of the fluid. What is the pressure difference between point from this one point to 2, that is 5 bar minus 0.01 bar into 100 to convert the bar into to convert a bar into kilopascal. So next we calculate, we get the pump work here. This is the work of the pump number 1. So after finding the work of the pump, then what is the aim is to find the value of H2. How to find H2 is, we know that work of the pump number 1 in the form of change in enthalpies is H2 minus H1. We already know H1, but we don't know H2. So we find H2. So we have found H1 and H2, the two values. Next is we need to find the value of H3 and H4. So this is the H3 value, this is the H4 value. So H3 is the pressure enthalpy. H3, we need to find the enthalpy at H3 and enthalpy at H4. We know that this point number 3 lies on a saturated liquid line. So we can find the H3 directly from a steam table. We know that the pressure at H3, that is point number 3 is 5 bar. We know that 3 point is a completely a fluid. Whenever something is completely a fluid, we can go to a thermodynamic data handbook and note down the values. So we will go to the thermodynamic data handbook. We know that it is a 5 bar. So we go to the pressure based chart, and at a 5 bar pressure, so at a 5 bar pressure, we note down the value of enthalpy HF. Why we are noting down the value HF is because it is a completely a fluid. So we know that at a 5 bar, HF is equal to 640.1 kilojoule per kg. So we note down the value of HF, that is HF is equal to H3. So HF is equal to H3, and next we know that we need to find the value of H4. To find the value of H4, we need to know what is the amount of work done by the pump. Find the amount of work done by the pump. We know the formula of the pump work of second pump, Vf, at a pressure of 5 bar into P3 minus P2. So we can look here, the pump number 2 pump number 2 lies between 2 and 3 and 4. So the pump number 2 lies between 3 and 4, and the pressures between 3 and 4 is 30 bar and 5 bar. So we need to substitute the value of 30 bar and 5 bar, and we can note down the value of the volume of the fluid, so at a 5 bar. So you look here, go to the pressure based chart. At a 5 bar pressure, you can note down the volume of the fluid. So volume of the fluid is 0.001093. So we note down the volume of the fluid 0.001093 or 28. Now into 100, convert the bar into kilopascal. We know the pump work. Now pump, we know the pump work. We know the value of H3. We know the value of H3, then we need to find H4. We know H3, we need to find the H4. So to find H4, we will use WP2 is equal to WP2, which we already know. We know H3, we know H3, we know H, WP2, we need to find the H4. So we substitute and find the value of H4. After finding the value of H4, what we have to do is, we have the left hand side values, we have found almost everything. Next we will move on to the right hand side values, that is 5, H5, H6 and H7. We know that H5, the pressure is 30 bar 400 degrees Celsius. At point number 6 it is 5 bar. At point number 7 it is 0.01 bar. So 30 bar 400 degrees Celsius, 5 bar and 0.01 bar. We can use the Moliere chart to find these values. So we can plot a rough Moliere chart. So this, the y-axis is the enthalpies, the x-axis is the entropy, and this is the saturated line. So will follow a line of 30 bar and 400 degrees Celsius. The point at which 30 bar line meets with the 400 degrees Celsius line is the point number 1, and we will note down the value of enthalpy. So that is the value of enthalpy. We can note down the values of enthalpy. This is the H5. If you move along this line, we can note down H5 value. Then if you move down, there is a line belonging to 5 bar pressure. When the point at which 5 bar pressure line meets with the vertical line from 30 bar 400 degrees Celsius, this is H6. Note on the value of H6, then add further draw the line. The point at which point 0.01 bar meets the straight line of isentropic process. Note on the value of H7. So this is the general Moliere chart. Before solving the problem or going to the Moliere chart, actual Moliere chart, always note on all the values. Rough Moliere chart is required. So, first of all, look at the pressure. What was the pressure earlier? So the pressure was 30 bar. So follow the 30 bar line, and the temperature was 400 degrees Celsius. Follow the 400 degree line. The point at which the 30 bar line meets with the 30 bar line meets with the 400 degree line, that is the point number 5, that is H5. Move horizontally and note down the value of H5 3240. Next, drop down because it is a which type of line? It is a isentropic line. So as it moves isentropically and as you move down, there is a pressure at which feed water is taken out from the turbine, that is 5 bar. If you look here, it is a 5 bar pressure. So 5 bar pressure line meets with the straight line. This is the H6. Note on the value of H6 to 800. Then you can move further down because it is still the expansion takes place until the 0.01 bar pressure. So if you look here, it is a 0.01 bar pressure line. It meets the straight line, and that is known as the H7. So you have noted down H5, H6 and H7. So after noting down these values, we can solve the problems and move ahead. So from a Moliere chart, we have been able to note down the value of H5, H6 and H7. Now, what will be our next step? So our next step will be to find the value of M. So we already know that what is the value of, we already know that what do you mean by value of M? We know that M amount of kg is removed from the turbine while it is being expanded from H5 to H6. When you remove when you remove M amount of steam, what remains is 1 minus M amount of steam goes on expanding from 6 to 7. So to find this value of M, what we can what are the point we can move on? We can move to the point that is H3. That is this point. This is the point at which the two all the streams meet. That is H2, H6, H3. That is H6 amount of steam is coming in from the turbine, and the water H2 is coming in from the pump, and H3 is moving out. So we can look at this feed water analysis. So H6 amount of steam, H6 enthalpy of the and H6 of enthalpy of M mass is entering the feed water, while 1 kg is leaving, while 1 minus M of H2 is entering. So 1 minus M plus M gets cancelled. What leaves is H3. So we can write this as a mass balance. Why H3 is equal to M into H6 plus 1 minus M into H2. So H3 we know have already noted down from the from the thermodynamics data handbook, and M we need to find. H6 we know from the Molière chart. H2 we know from the thermodynamics data handbook. We have calculated. Now we will substitute the values and find the value of M. So after finding the value of M, we can move ahead with our problem. So first we will calculate the work of the pump 1. M, work of the pump 1. So work of the pump 1 is what? 1 minus M into H2 minus H1. We know the M value, we know H2 and H1. So next is work of the pump 2, that is H4 minus H3. Next is heat input, H5 minus H4. Then what is the turbine work? H6, H5 minus H6 into 1 plus 1 minus M into H6 minus H1. H7. We note down all the values, substitute, we'll get the work of the turbine. The net work is given by WT minus WP. Then efficiency is given by W net divided by heat input. So we calculate the efficiency of the Rankine cycle. Similarly, we can calculate the steam flow rate, that is, steam flow rate is, we know that steam flow rate can be calculated by a formula which we already have solved in the previous problem, that is equal to steam flow rate is equal to 1 by W net. W net we already know this. So the W net into 3600 to convert kg per kilowatt hour. So 1 by W net is the steam flow rate. So we have solved this problem. The main thing you need to remember is, if you look at the diagram, you can easily write down these formulas. So we'll go to the, if we go to the diagram, we can see here the work of the turbine is given by H5 minus H6 into 1 kg mass, then H6 minus H7 into 1 minus m kg. Then pump work is H1 minus H2 into 1 minus m, then H3 minus H4 into 1 kg for a pump number 2. So this is how we have calculated the values of the pump work, work of the turbine, and the steam flow rate. So write down the same problem as an assignment and submit. Thank you.